The broadcast is now starting. All attendees are in listen-only mode.
Hello, welcome everybody to Coffee with Caleffi, July 2014. Where does the time go? Well, thanks everybody for taking time out of your day to tune in today. And hi to Nathan and Max and some familiar names on the list here. The webinar that we're going to do today is actually in response to one of the requests. You know, we ask you at every webinar that we do if you have any ideas of topics you think you like to see or that we should cover, send them in. And this one came in a couple times, so I'm going to give this a shot for piping and component insulation. It's something that we at Caleffi can help you with. We're not an insulation company, of course, but we do have some unique things that can help a contractor with this. So we don't have a lot in our different hydronics issues that relate to, you know, insulation specifically. We show some of the insulation products that are available, you know, to insulate like a disc L or something like that. But other than talking about bare pipe giving off heat where you might not want it, we don't have a lot of data or information in that. So it gave me a pretty clear slate to go with this. But Fundamentals has a lot of good information that pertains to heat loss and piping and different things. So if you want to run through that one, there's some good ideas in there. So this is, I grabbed this off a YouTube video here a while ago. This guy was driving around and he heard a noise under his car, and he looked and this little kitten was up inside the coil spring there, and it was a YouTube video, and they showed him taking that spring out from under the, I guess, a mini pickup or something, and pulling the little kitten out of there. So it kind of reminds me of that Subaru commercial where, you know, they see the smashed car and everybody's saying, oh, they live. Well, the kitten did live, so there's the good news. So what I wanted to do, there's two things that I've noticed that seem to get overlooked or forgotten sometimes when you're doing a hydronic system, either a hot water system or chilled, but not so much a chilled, but more probably a hot water system. And probably more so on the residential side. I would say most commercial jobs, if it's done by an engineer, there's going to be an insulation spec that's written up for the job that, you know, requires a certain thickness and a certain type of insulation. And generally, you know, another contractor would be pulled in to do that. I don't know that on a big job that the mechanical contractor always does the insulation, but on a residential job, I think there's a couple reasons that happens, at least from my viewpoint and from being in the business myself, is what happens. You know, you go in with good intentions that, oh, you know what, I'm going to do a really nice insulation job on this at the end, and you get to the end of the job and maybe the hours went over a little bit or something like that, and then it's a spot where, you know, the homeowner really doesn't know that it's going to be insulated or not. So I think it's one area that kind of gets omitted from the job. The other one I would say would be water quality or fluid quality, you know, the right way to flush a system and, you know, how to handle that. We are going to go into that. It'll be next year. We kind of filled up our schedule already for this year, but we've got some industry experts that are going to help us with fluid quality. So stay tuned for that, but I will cover the insulation today. Now, one of the things, too, is that, you know, years ago we didn't have a lot of data on, you know, well, how much am I losing in the boiler room? You know, back in the day when we were still putting atmospheric-type boilers in and we had louvers to the outside, allowing combustion air, sometimes high and low, into the room, there's quite a bit of infiltration. And, of course, the heat from your boiler and your piping and stuff is just going to the great outdoors. I remember a job up in, it was up in Deer Valley, Utah, when we were working out there, and it was a big high-end lodge, ski resort lodge right on the slope there, and I went up there for a service call. I don't remember exactly what it was for, and I walk in the mechanical room. I had to shut the water off to do some service work, and it had a whole row of big cast iron boilers. There was snow melt and domestic hot water and radiant heat in some of the rooms, and there's probably 4 or 5 big cast iron boilers. And at the end of the room was a louver system. It was about the size of an average garage door that would open and close when boilers would kick on. It was sectioned off so different parts of it could open. And there was a 2-foot-high pile of snow inside that mechanical room, probably 10 feet away from the boilers from all that cold air blowing in there. So obviously the heat that those boilers are trying to put into the building, some of that's going right out that door. Now, obviously, a lot of that goes away these days as we're using more and more sealed combustion type of equipment, and we're running lower temperatures, certainly on a radiant than we did with the cast iron and copper tube boilers. But there's still a reason to do a good insulation job. So also what we have available now that we didn't certainly 20 years ago when I looked at that job was a way for a contractor, a designer to identify that heat loss and put some numbers to it. So as I was preparing for this, I just kind of Googled around for a lot of different Google searches for like tank heat loss, piping heat loss, fitting heat loss. And what we have available to us now is a couple examples here. Some of these are free online. If you look for these, are these little either simulation programs or software programs where you can put some numbers to this. So if you know you've got so many fittings, so many feet of pipe in the room that's not insulated. You know, what kind of numbers are we talking? We're talking 10,000 BTU per hour that we're losing, 100,000 BTU per hour. So now with all these programs that are available with just a click of a button, you can start to put some numbers to that and see where this starts to make sense as far as the economics of it. You know, probably the other thing that happens a lot here is, you know, people say, well, the energy's not that expensive right now. I don't know that the value's there to spend another X amount of dollars to insulate to save X amount of energy. You know, it's until I think the point comes where the energy costs a lot more than it does now. I don't think people are paying attention to this. So anyways, that's my thought on it, and so we'll go through this. So these are just some of the all the different software programs that I picked off the just a Google search for this. There's actually some that are actually like little simulation programs. I saw this one. It was a YouTube demonstration, which I couldn't put on here, where you could actually change the parameters. It's almost like the pump was running through the system. You could change the pump flow rate. You could change the wind speed or the air temperature in the room, the flow rate of different heat emitters, and you could watch what that did to the heat loss number on a certain circuit that you defined, similar to the one that you see there on the left. And then some of them are just a little basic graph like you see over there from the Engineering Toolbox website there, that you can just see some different thicknesses and what that will do to the heat loss off some piping. This is one that I use quite a bit. I really like this HDS, this Hydronic Designs software. I think we've talked about this in other webinars for different things. And across the top there you can see a toolbar of all the different things that it can do for a designer. Really simple to use, fairly affordable, this program. But it has a really nice heat loss calculator for piping, and you can see what you can do with this one is you can, over there on the left, you can choose the type of fluid, you know, different percentages of glycol, different types of glycol. And then right below that, you can put in your flow rate, your fluid temperature going into it, you know, the length of pipe, the air temperature surrounding it, the type of pipe. And then you can just toggle in and out different types of insulation, whether it's going to be foam, different thickness of the fiberglass and stuff like that. And then it's going to give you the number. You just hit enter and it spits out these numbers here at the bottom. So you can see going through this section of pipe that I've defined here, how much temperature you're going to lose going through that, the BTU per hour lost from that. So this makes it simple to do the piping. It doesn't do a lot for fittings and some of the other components like, you know, tanks or hydro separators or stuff like that, but certainly it can get you some numbers and get you in the ballpark on just what the piping in the room is losing to the room. Now, the argument could be made that, well, you know, whatever heat loss is getting escaping to the boiler room, it's inside the building. It's inside the structure of the envelope. It really isn't loss per se, but I guess my answer to that would be, well, I mean, you're paying to get that energy to the heat emitter, not really to the boiler room. There's no reason for a boiler room to be 85 or 90 degrees when maybe the upper levels of the building are calling for heat on a design day and just struggling to keep even. You really want to make the heat get to the heat emitters and not lose it to the mechanical room where it's not really helping the comfort of the people in the building. So that would be my answer to well, the heat loss is in the building anyways. So that's basically a couple different examples here that I wanted to show you. If you change some of the parameters, that you can see how it makes a difference. You can see this one here, no pipe insulation on this example is what I'm showing you here. So you can see the heat loss there at 7,900 BTUs per hour from that section of what I put in there, 1-inch copper tube. And now just by putting a little bit of insulation in there, I'm talking about just a 1/2 inch of foam rubber, maybe an Armaflex brand of that type of insulation. You can see that's cut that down considerably. So there is some value to that. Now, again, you have to pencil in the numbers and see what works for you on as far as what's in the budget to do that. And these can get pretty sophisticated, some of these programs. I got permission from this company. I think it's a company up in Ontario, Canada, that developed this software here. And I thought it was fairly affordable. I think it was like $79 or something for this little loss program here. But you can see a lot more data input here. You can look at the not only the air temperature, but the type of insulation, the permeability of the insulation, any air occurrence. If it's maybe it's a separator and there's a layer of air on top of the separator, a little layer of air in there, you can calculate that out. So you can really drill these numbers down pretty tightly if you need to do that. And you're in the number crunching. There's certainly programs out there that'll let you take it to that level, so to speak. Now, a couple other things you can do if you want to identify some heat loss is just use some of the different instruments that are available out there. I mean, certainly your bare hands. I mean, you can feel a pipe and tell if there's temperature coming off that pipe. These little pocket thermometers you can stick different places. You know, I usually take a Velcro band or something like that and tape it on and see what kind of, you know, heat's actually coming off the surface of the pipe or the surface of maybe a radiant manifold that's in a closet somewhere that's putting heat out in the closet. There's a lot of different strap-on sensors. A lot of these will work with your multimeters, either with a, you know, this type of a clamp-on meter. You can get these, you can get single and dual ones, so you can get a temperature differential with these too. But again, you can see little Velcro straps on those that you can just strap it on and identify something. I think most of the guys now have these little point-and-shoot infrared guns. These are little battery-operated guns that you see a little like kind of a laser pointer. You see whenever you go to trade show, guys are pointing up at the ceiling and at the piping and at people walking by and stuff like that. It just shoots a temperature and just gives you a readout there. And I would say probably the granddaddy of heat guns would be the infrared cameras, and these have come way down in price, and you're seeing more and more contractors and people have these infrared cameras where they can look at losses in the building or something like that. And here's an example of just one, and I know there's a lot of brands out there now. FLIR is kind of an industry leader. They kind of developed this technology and made it available to you know, the contractor level with some of these. I know they're out there for under $1,000 now, some of these point-and-shoot contractor versions of this. And you can also lease these. I know FLIR has a program that if you've got a job that you want to do some testing on, that you can just borrow one or lease one, and sometimes they'll apply some of that towards a purchase price. Not only for finding temperature, but if you've got a leak in a pipe and it's getting that insulation, maybe you've got that fiberglass insulation on all your piping and you've got a pinhole leak under there somewhere, the infrared camera, you could point at that insulation and see that you've got a hot spot in there because you've got a leak that you might not even know is underneath that insulation. So one of my thoughts on this, and I'll get off topic here for a second a little bit, but well, this is a picture my son Max sent me that he shot at a job site. That's in C, by the way, that number there. It's 147 degrees. But there's a job where the whole job was insulated. The piping was nicely insulated. I don't know if you can see in there, but the fittings also, they've got, you know, the corners all insulated, but the valve here was uninsulated. Now, sometimes that's done just so you've got good access to the handle there to turn it on and off. And, you know, in a heating application, again, that's maybe, 4 inches of distance there. It's not a huge loss there, but sometimes when you try and wrap these or try and insulate them, it makes it awkward to use the shut-off handle on them. So maybe that's the case here, but you can see the infrared cameras really jump out at you when you shoot something that's got that kind of temperature just coming off the brass ball valve there. But getting back to this infrared camera, here's an example of another. I think Max sent me these too. And you can see that FLIR will spit out all this information, and you can put all these little crosshairs at different points, and they'll tell you what all the temperatures are here. So here you can see we've got one of our hydro separators in there, which has an insulation jacket that comes with it. And you can see that's insulated, so we've got some pretty low temperatures there, but all the components piping up to it, and you can see the temperature of the circulator pump on the bottom of the separator there. And down here is just the view of that without the camera. So pretty powerful way to show people, you know, maybe you're going to a customer and saying, you know, we can help you a little bit with your fuel cost here if we just come in and do some insulation and just, you know, take some shots like this and show it to them. And it's an eye-opener when you see it in living color like that, as opposed to just going up and touching some pipes. There it is, getting back to my drone. So I thought this was really clever. This is a contractor up in Minnesota that he's got one of those little drones that you can buy now that you can put cameras in. And when he does a loop field now, he takes that up so he can see where all the loops are, where they are in relation to the yard and to the house and stuff like that. Man, I wish these were available years ago when we were putting septic and leach fields in, because if you go out and you try and pump somebody's septic tank and they have no idea in that 15 acres of land where that was put in, this would have been a handy thing. But also for big radiant installations, if you want to know where your tube is in relation to maybe footings or something like that. So looking at this, I thought, well, gosh, why couldn't you just send an infrared camera up in one of these drones? And then if you're doing trying to find heat loss or leak in a radiant slab in a warehouse or a big building or something like that, just kind of motor that thing around and look down. So this is what they look like. I've seen these at different places. I think Verizon store, Milwaukee's got one up there where you can put your little iPhone or something for like $350, $400. So they're getting fairly affordable. I don't know there's a bit of a controversy as far as what you can do with the drone and where you can fly them before people start shooting them down on you or something like that. But that would certainly be a way to look at a big job for some heat loss. You know, you could fly it right through a building or through a big mechanical chase or something like that and find a leak. And apparently these are getting easier and easier to fly than the early versions did a lot of crash. And so just something to think about there, both for you know, your loop fields or your radio installation, but possibly put an infrared camera in one of those. And I'll show you some of the jobs that get sent to us. Now, keep in mind, some of these jobs are in progress when these slides get sent to us, so there might be some more installation that's been done on here. But here's an example, a classic example of a job that's been well insulated, probably done by a professional insulation contractor. A couple things I think of when I look at these that, you know, maybe the industry should start thinking about, or maybe the manufacturers should start offering, is insulation for expansion tanks. When you start talking expansion tanks that look like, what, 40, 50-gallon capacity here, I mean, you certainly wouldn't put a hot water heater down in your basement without any insulation on it at all. So I'd like to see these being offered with some kind of insulation shells or jackets that are available to do that, because that's, you know, it takes a little bit to wrap that and make it a nice, neat job where you have to get just sheets of the fiberglass and wrap it around there, all the fittings and the you know, the different shapes of that tank. But I know some of the European solar tanks that were being imported would come with like a zip-on foam jacket that you would put it in there, make all your connections, and this thing went on with just a big zipper on the front that you'd just put it around there and zip it on. That made it nice that it didn't get damaged during the shipping, and then you could make sure you didn't have any leaks on all your connections before you put your insulation over it. So that might be something to consider for tanks like that. And the same thing here with the hydro separator. I mean, that thing might hold 20, 25 gallons of hot water. So really what you have here is a radiator or a panel radiator if you don't go around and insulate that. So, you know, it could be argued that, well, that's the heat for this room here. You know, we've got some water pipes and other things in this room. There are no heat emitters that I can see in here as far as radiators or fan coils or something like that. So maybe some of this heat leakage is just, you know, keeping that room at a comfortable temperature to keep the piping protected in the wintertime. But that's a nicely done job, both for the piping as well as the insulation detail. You know, as I started searching around, I said, gosh, I don't know why somebody hasn't thought of those expansion tank insulation jack. And so I found this UK website, a couple of them. Actually, one's an Irish site there on the left, and one on the right was a UK kind of a homeowner type of store that you can do buy energy efficiency products. And there's a lot of open systems. In fact, we had a webinar earlier where we had one of our reps from over in the UK sat in and told us a little bit about the systems that they put together there. And they have these tanks like you see over here on the left, and this is actually an open vessel, so they don't use a bladder tank just up in the highest point in their building, up in the attic or up at the upper level. They'll put one of these tanks in here. Well, obviously somebody thought that, you know, there's a market that we can make these little jackets that you could zip on or Velcro on there or something like that. So there's one for one of the square tanks up in an attic. But I did find this company that makes these small sizes that would go right around an expansion tank or a small indirect water heater or something like that. So certainly that's something you could, we should be able to come up with. Now here's another example of a very well insulated job. You can see here that all the piping, not only is it insulated, but it's got some jacketing on it. You can see it's got like a glossy PVC. This is kind of you can see by the glass over here, this is kind of visible to everybody. So they wanted to make a really professional, great looking insulation job on that. So you can see they've wrapped the hydro separator and actually put embossed aluminum covering over that also. And then all the piping going up to it is covered with, of course, all the labels and stuff on it. So that's pretty nice. And you can color code this too, this insulation. If you're running it on, you know, gas piping or something like that, you could use the color that's required by code for that. But that's a 10-inch hydro separator there with a job with all the piping going to it. Now Caleffi, knowing that this is important and knowing how hard it is to go on a job and wrap around all these different connections, we'd have to get, you know, the loose wrap around this here and around the flanges and all that. We do make insulation shells for quite a few of our hydro separators and some of our other products. I'll show them as we go through here. On the smaller sizes, you'll get this expanded polyethylene is what it is, cross-linked polyethylene type of jacket. You can see it's kind of a clamshell design here. So once you pipe this, one comes in from the back. There's some sticky tape here that you can pull off and put it on there and stick it on there. And the other thing that's nice about this, if you did have to get in there and change something, if you want to work on this or for some reason, whatever reason you have to get to these bolts and stuff, you can easily take this off and have access to it. So on our smaller series from 1 inch to 2 inch on the 548 series, you'll see this black foam jacket here. On larger ones, we've got this. It's a little different type of insulation. It's expanded polyurethane on this instead of polyethylene. And this is it's got a couple different pieces to it. You can see the two sides, and then it's got the caps that are like a plastic cap, and then you can see the donuts for the top and the bottom there. So we try and make it easier for that. I believe there's a DIN standard in Europe that a lot of the components over there are required to have insulation shells or jackets put on them. So you'll notice some of the products you see when you go over there, like manifolds, radiant manifolds. You might see some of these extruded polyethylene jackets that are built to fit right on that manifold and stuff. So again, it just makes it easier for the installers. They don't have to figure out how to wrap around it. And here's an example of one of the hydro separators, one of the larger hydro separators here. You can tell that by it's a flange version, and you can see the jacketing and the shell on that there. It does leave you access to the bolts and stuff like that. So again, if the contractor came back and insulated this piping, he could match right up to that companion flange there, and it just makes it a lot easier to have a nice clean detail there. I was up in, this was a few years ago, I was up in Calgary, up at one of the expos up there, one of the Foothills Conference or something, I don't remember what it was, and I had an opportunity to go take a tour of the NATE, which is the Northern Alberta Institute of Technology. It's basically a trade tech up there. And the class was in session that day, all the classes were in session, and we had a chance to go in. They actually had a room where they were doing pipe insulation, and they had all these different piping setups throughout the room, and these students were in there wrapping the pipes. There was tees, and there was fittings, and there was valves, and big gate valves with hand wheels and stuff like that. And I'll tell you, it's an art to do it nicely and neatly. And I had to pay attention to this one gal, and we stood there for a couple minutes, and it reminded me of my Aunt Rosemary, who was a seamstress. And whenever I'd go and visit her, and I'd go into her sewing room, and she had all these like pieces of fabric that were cut all these special shapes, triangles, and all these different things. She would do like a lot of wedding dresses and stuff like that. And this one gal that was in there wrapping all these fittings and stuff like that was so meticulous how she was doing this. I mean, the work she was doing was beautiful. So they were wrapping it, with the gauze and the plaster and stuff like that. But it almost looked like all that was squeezed out of a 3D copy or something like that, just the way she was detailing. And this looks like some of the work that she would probably do if she was out on the job doing that. But this is actually it's allegedly one of the largest hydro separators in the world. That's a 36-inch hydro separator. So there's some serious insulation cost and product going into that job there, but you can see how they've got everything on the flanges and everything all insulated, and actually how they've got the loop hangers there were insulated in too, so you don't have exposed metal with loop hangers are hanging all that big piping off that. A nice installation photo there. I'd like to say we built that hydro separator, but that is a competitor's product. Johnny back in New York City does a lot of retrofits, a lot of remodeling on the old buildings here, and you can see some of the insulation detail that he's done here. Again, everything's insulated here, but the expansion tank, you can see the piping and pretty much the fittings and the nice detail everywhere, except this big tank here, again, is like a 40-gallon panel radiator, so to speak. It takes some care to be able to do this type of work, where you've got to support this piping under a unistrut cradle or something like that and make sure that the insulation can stand on that. So that's a really nicely insulated job, yet you've got access to all these pumps, access to its gauges here, access to the isolation valves and stuff on the pumps. Now, one thing, and I think I've got a better picture of it coming up, but you don't insulate the pump motors. These motors have to be able to have some cooling. Certainly they're fluid cooled if it's a wet rotor pump. It's going to be cooled by the fluid in there, but there is a temperature limit on this pump, so if you're running 180, 200-degree water through here, if that motor was insulated, you could exceed the temperature on that motor and cause some problems there. I call this the Michelin Man because it kind of reminds me of that, but this is an example of one of the preformed shells that we offer at Caleffi for our disc gals. And this is a 2 or 3 piece shell here, so you can just, after you get your piping and stuff in, you can see it's got a little belly seam here where it comes apart, and you can put that on after you've done all your work. And we're trying to offer more and more of these. Here you can see one for the disc gal on the left, and of course the insulation shell that goes with it. We're selling it as an option, just so if people want to do that, if they're going to insulate the system. This one would work good for chilled water too, and we'll talk about this as we go on, but it's critical on a chilled water system that you don't have any exposed metal because that's going to condense, it's going to sweat, it's going to drip. So by having a nice tight seal around here and around the top here and around the bottom, the only thing that would be protruding from this one a little bit would be the cap. I suppose you could put a little piece of foam on that or something too, but that one really does tighten everything up. And then this one here, it's got edges on it that you can match your insulation tightly up to it. So you come over here right across the fitting, the adapter that goes into this, and just match it right up there. Most of the guys that do in chilled water, they'll actually glue that connection there so you don't get any air temperature going there causing sweating on the pipe. And I'll show you some that do, in fact, leak like that. And here's an example at a training room at one of our reps out in California. They've got a little training room showing some of the products, and there's an example of one of our disc gals with the foam jacket. And it's kind of a small picture, but that's the jacket that was put on after they assembled that working display. The quick setter, we actually have two different options for this quick setter, which is a really popular valve for us. This is the basic insulation shell that it comes with. Again, it's a two-piece. It's got a little bit of a sticky tape on there that you can just peel the tape off. It's double-sided tape. One side it's already in there, and just peel it off and stick it on there. And we do make this other version here just a little bit longer. It'll cover down a little bit further and actually seals around this a little bit better. The guys that are doing geo work or where they're going to have chilled water, this is another option that we've got for the quick setters. You are going to have a little bit of exposed surface here. It's hard to get, if you're going to be able to have access to that ring, of course, you don't want to insulate right over the top of that. So there is going to be a little bit to allow you to view this, the gauge on the end of that. So we can't cover it all up. Now, one thing I will tell you on these little jackets, sometimes if they've been around for a while, this little tape starts to go lose its stickiness, if that's a word. And all you have to do is just take a piece of like copper thermostat wire or some big staples or something like that, and after you put it together, just push this in. You can see across the two halves, and that'll make sure it stays tight together, because I've seen some of these kind of, the sticky goes away and they start to spread open, but that's a little trick for it's just basically called an insulation staple. They use that sometimes when they're putting fittings, two halves of fittings on before they put the jacketing on them too. The Hydronic, obviously another product that would be hard to insulate on the job site if you had to wrap around that with strips of insulation. So that also comes with a black two-piece shell for that. You can see it on the top. You can make your connections, make sure you get leak-free tight connections everywhere, and then come back and put the two halves of it on, one from the back and one from the front, and it ends up looking like that. Even got a little label to show you a little bit about the functionality if somebody walks up to that and someday and says, what the heck is that thing? What's it doing? Well, there's a little, the logo on it has a little schematic of how the piping works on that. So kind of a multi-purpose sticker on there that tells you what the product is and also what it's doing. And, of course, this would be another product that we offer, one of our hydro mixing stations. This is one of our newer ones with the variable speed ECM pump on it. And you can see we've had these jackets molded just so all the components fit in there. You can see actually a little wrench in here that you can work on that balancing valve there, or isolation valves. You had to shut it off and work on it, so that's captive inside there. But as you can imagine, it's expensive to make these. You have to make a die first that allows you to mold these shapes, and then you squeeze that product in there. But it just really makes it nice for the installer to be able to have a insulation product that looks like it was built to fit the components that it's covering up. Some of these will have windows for your gauges and stuff like that also, and of course the end of the motor would stick through the top half of this jacketing here. And all our tanks that we sell, our solar con and our thermal con tanks, both for solar and for different storage tank applications. These are foam-injected tanks. You can see we've got 1.5 to 2 inches of foam. It actually meets the standard here of an R14. What's nice about our tanks is that we foam the tops and bottoms also. So underneath here on the bottom is injected foam, the same on the top. So there is really no seam. Back in the day when they were using fiberglass blankets or something to insulate tanks, you had a little seam on the top where this wraparound here met the little kind of donut that went on the top of it. And certainly if it was a chilled water application, maybe in a thermal con, that would be the potential to leak. And then, of course, you're going to have water running down the inside of your insulation, and you could rust through your tank or something like that. So we give you a nice value and also a nice one-piece foam there. And then a nice jacket on the outside to protect that foam. And the nice thing about doing an injected foam like that is you don't ding up your jackets like you did with the fiberglass when you're moving them around. If it was just fiberglass that was soft under there, you could actually dimple or dent this jacket. So by having the foam, it makes it a nice solid feel to the tank when you're moving it around or install it, if you have to roll it across the floor or something like that. And these are tested to the the HRI testing standard. There is a standard for the loss on these tanks, the heat loss from the tank, and of course our tanks are tested to and meet that standard. But that's the key right there, is enough foam in there and a good job that you've got a tight seal on all the edges of that tank. Now, know that when you go into these and you take pipe insulation to that, if that's going to be a chilled water application, you want to make sure that you get your insulation that's around the pipe all the way in, that it goes against the insulation inside the tank. Now, sometimes you might have to work on that hole a little bit. If you're going to put a piece of insulation on there that's a 1-inch wall thickness or something like that, you might have to make sure that hole's got enough room there that you can get that insulation tight against the tank, or that's where you're going to have a leak and a little bit of potential for rusting if it's a chilled water system. So we take it as far as we can, not knowing what's going to be out on the job. We try and make it as easy as possible for you to insulate up to those tanks. And here's a couple examples. This was done by a professional insulation contractor, believe it or not, but you can see what happens. This is a chilled water tank, and you can see some rusting where some exposed metal here on the ball valve handle. There's actually a little, it looks like a junction box or something there that has a wire, maybe a sensor or something going in there. And obviously that's touching the pipe, which has chilled water going through it, so that whole metal box is it's going to rust, and it's sweat, and it's condensing from the temperature difference between the ambient temperature and also the temperature going through there. And you can see the same thing here on that ball handle. And that's a hard detail to do, like I showed you earlier. You want to have access to this handle if you have to turn this off to service a pump or a component that might be downstream. So, it's a little tricky to insulate that, especially on chilled water. But you can see what's happening here is it's obviously dripping off the bottom where these parts are sweating. And the same thing over here, I'm thinking that we needed to, we're going to go to a stainless steel screw. You can see the screws on this quick setter here have got a little bit of rust stain because they're carbon steel, so, and a little bit of dripping off the ring here. Again, to wrap this, maybe get some, you can buy tape, either kind of a foam tape that you use on the, maybe an Armorflex type of foam. You can buy that in rolls that you could maybe take some half U shapes and go around this and tighten this up a little bit more. But again, you need access to that window, to that ring, and also to the valve up here if you are going to do some balancing on it. So at some point, you got to have access to that, but you want to, when it's all done and balanced and stuff, you want to cover that up so you don't get that dripping. Another nice job sent in to us, Andy Stack from Stack Plumbing and Heating back in Ohio. This was a job that he's done. You can see they've replaced this old boiler with some high-efficiency equipment, and he's got one of our separators there, hydro separators, nicely insulated up to it. But here we go again. There's a couple big thermal expansion tanks on the system that are probably that's about as much heat as this room needs in the wintertime to keep it warm in here with all that piping insulated with a high-efficiency boiler that's not going to leak as much heat as this old steam system obviously did over here. How am I looking here for time? Yeah, and we get a lot of nice pictures, and I'm appreciative of pictures that come even on a residential or small commercial application that the installers, they're taking the time or they're hiring the people to come in and do the installation. Again, you can see our separator here with some couple Lochinvar boilers piped into that. And here we go again, expansion tank. Maybe I should invent that and market these little zip button jackets for all these different tanks over here. But yeah, keep them coming. Thanks. We appreciate getting job photos, and we'll use them and certainly credit you for the information if there's something you want to show us or you've got something unique or a detail that you've learned that could help the rest of the trade. Send them in, and we'll get them included on some of our blogs or some of our webinars. All right, so this is the pump manufacturers, of course, that are stepping up here a little bit too and offering more and more of these insulation shells. Here's one of the new Magna pumps, and you can see it's got a multiple-piece insulation shell that goes around it. Again, important that this motor stays uninsulated, and this one here is actually made with this little separation between the motor and the iron body, the volute here, so that can be run on a chilled water system without causing damage to the electronics out in the head of this motor here. So. And here's an example of one. You can see, obviously, this motor's running, so that motor's staying warm and staying dry, but you can see the sweat, the condensation coming off of this from the temperature difference of the chilled water going through that. So, again, a two-piece shell like that certainly makes it easy for you to be able to do a nice, tight insulation around this whole component here and then bring your pipe insulation right up to the ends here. So I think you're going to see more and more manufacturers offering these preformed shells just to make it easier for you to do that properly. Another classic example, here's one of our solar pump stations. And you can see it's got a pre-molded shell here. that covers everything. You can make your piping connections here. What I like about this one, it's got a nice big diameter when you put these two halves together that you can actually push the insulation from the solar tubing, and I think I've got some pictures of our solar flex coming up. You can push that right down so it meets right up to this fitting right here, covers your connection there, and then it's got a nice seal and a nice look to it as it comes through the jacketing there. And again, they come apart so you can get in there if you have to service something there, if the pump ever has to be replaced or removed or you need to get in there and work these valves. You can just pull the front half of that off and have access to it. Now, one thing to keep in mind is the temperature. If you start talking about solar applications, you know, the stagnation temperature of a collector, you know, well over 300 degrees, evacuated tubes probably well over 400 degrees. So you got to pay attention to that when you start insulating solar tubing. Certainly the stuff close to the collector. And they, the companies that make insulation, like here's an example of an Armacell brand, they actually make a solar insulation now. A couple things about this: it's a little thicker wall, but also it's a higher temperature insulation to be able to withstand those temperatures. So probably a little bit more EPDM in here than other products to be able to do that. But we do make a product, a Solar Flex product, that makes it easier for installers to go up to their panel. And what we do here is both tubes are insulated, and also there's a wire in here. But this is a high-temperature insulation, and you can tell high-temperature insulation if you got a good nose. Just sniff the end of it. It has a real strong kind of a rubbery smell to it. It's probably a good quality insulation if it just smells like foam, like the typical foam that you'd see at a box store type of insulation. You don't want to use that on solar because you're going to end up with just a big gooey gob dripping off your pipe someday. So you can get the pre-insulated tube from us, or if you have to do some short sections of straight piping, I would encourage you to look for a solar-rated insulation on the solar installation. And, of course, if you want to cover that, there's different types of jacketing available. This is one on my workbench, a little job that I'm doing for a neighbor. We're putting a solar panel on his house, and I'm going to use some of the Armaflow that's being piped with copper pipe. And so I've got some of that 1-inch thick walled high-temperature Armaflex here, and then since it's outside, it's going to come from the collector right down into the roof as short as I can make it here. You can get these preformed aluminum jackets. That's a number 2, which happens to fit this insulation. It's about 2-inch outside diameter on that. You can also get them in a PVC. I think for outside use, I think these aluminum ones last a little bit longer. Certainly if you want to blend that into the roof, take a can of spray paint with you. When you're all done, spray paint it black or brown or whatever to match their roofing. But basically, put this on the piping. I usually split this down the center here so I can put it on 2 halves, and then a couple of pop rivets or sheet metal screws to hold the 2 halves together. Now you've got a good insulation detail. You've got it nice and tight here. This is actually glued together with some contact cement adhesive. And then it's protected from the UV and from the elements by putting the jacketing on it. Now I guess that's a double slide there. Sorry about that. That just shows the disco, again, insulated with the jacket that we offer. Now here's another product that we offer, and this is kind of unique in that this is a manifold that we make for geo applications, and there's no insulation on that, and you don't need insulation on that because what we did is we built the airspace right into the manifold sections. You can see how this manifold's built with all these different sections, kind of like a Lego. But if you notice on the end detail here, all the slots going through that is airspace. So I mean that's what insulation really is trapped air. So we build that into the manifold for you, so I don't have to wrap that. Now we do give you these little end caps here because the ends of these are brass, so these will go over the end caps so you don't get any sweating going on there. And you could put a piece of Armacell or something around this vent here if you wanted to insulate that a little bit more too. But by having this made out of, number one, a composite material, so it's not a conductor, and then also by putting these channels in there, it does a couple things. Obviously, it has to do with the structural integrity of this also. But it did the double whammy there is it gives you the insulation as well as the strength for the modules that assemble together there. So that's our GeoCal manifold. It's available in a number of different port configurations. And there's one all installed. And a couple things about this. Thanks, Mike, for sending this picture in. But you can see he's used those. Some of our quick setters were put on this so he can balance or adjust the flow rates to the different loops on this loop field. And then he's used these longer insulation shells so you can see that goes and it butts up tight against the bottom of that the geo manifold there, so it makes a nice tight connection there. And here's an example where he's taken some of that foam tape and he's just wrapped around some of the fittings here where there wasn't an insulation jacket available, so he's brought his foam up. And here it looks like he's probably just using foam because, again, not a high temperature application here. Being a geo loop field, he's not going to worry about these melting off like you might on the solar. So foam insulation, some of the foam tape put right up to the geo manifold. And here's a little better shot of the end cap. So that's sealed tightly, and a nice job there. Thanks, Kevin, for permission to use this photo here. A nice job again. You can see the motors aren't insulated. Now here's one where instead of using the preformed shell, maybe they're not available for this model, this size of pump. He's done a pretty nice job of wrapping that kind of almost like a diapering type of wrap like you would do on a baby, where he's taken and cut these kind of wedge-shaped pieces and wrapped them from a couple different directions. So he's got that velour wrapped tight up to the fiberglass insulation here, and then nice and tight up against the motor here. So that's another way of doing it. You can see one of our thermocom tanks in the background, and so he's got that insulated right tight up to the tank, and then you can see the fittings that he didn't use down here where he's put nipples and caps on them. He's also put some insulation on that, because again, with these chillers here, you don't want all this pipe sweating and dripping in the mechanical room here. So I thought that was some nice details and a nice piping job, insulation job also. Now, what type of insulation? There are different types of insulation available that can be used for depending on what your application that you need is, but probably the most common that you're going to find out there would be either the fiberglass type, and this is just a cut sheet from the johnmansfield.jm.com website. It tells you what this can be used for. The fiberglass does indeed work on chilled water systems if you use the right type. This is the product they recommend for using on chilled water, and some of the information that they give you there. And then other guys like to use the black, more of a foam or a EPDM type. A little bit easier to bend around things. You can kind of get away with not so many miter and cut joints with some of this the foam type of product. But again, it will give you the specs for temperatures and different things on that. Why is it important to keep that from dripping? Obviously, here's a job where something's been sweating and dripping up inside that ceiling or leaking. Now, not only do you get the stains where you have to go around and change all these ceiling grids, but obviously you've got the potential to get some mold or something growing there. So it's not just to keep the heat or the cold into the pipe, but also to keep water from making a mess somewhere on the job if it does sweat and condense, and then, of course, the potential to grow some black mold there. Oh, this is a job I did in 1999. Oh, my gosh, I was young then. And you can actually buy, this is PVC jacketing. This company is, they're down in Tempe, Arizona, I believe, is where I got this from. And what's nice about this company, they'll sell you small orders of it. You don't have to buy hundreds of feet or boxes of it. But this was a primary secondary loop. Here's my boiler over here. Here's my primary secondary. And basically what I did here is my primary loop. And this is a return from all my manifolds. And obviously it just goes right through this loop here. But I wanted to do the color spectrum, like the rainbow, which is Roy G. Biv. You remember that from high school or from grade school, where they taught you to remember the colors of the rainbow by Roy G. Biv, being red, orange, yellow, green, BI, indigo, and violet. So that's what I got there. So yeah, I mean, if you want to do a fancy job, you can get different colors like that and kind of spruce it up a little bit. This is another job I did for a big radiant job here with a couple cast iron blades, and the same thing here. I chose to go with all yellow, and you can actually buy the fitting boots to match it. You can get T-fittings and stuff like that. Here's a case where I wish you could have had some of those little preformed shells to go around the pump bodies there, but you can get different colors. You could have, red maybe on the at the supply and the yellow on the return or something like that. So if you want to do a really fancy job, that's a company that'll sell you these. You can buy just the covering from them too, but the Tech-Lite's kind of a melamine type of insulation. It's not a fiberglass and it's not a foam. It's kind of a white product. They call it a melamine foam. So if you're interested in that product, there's a place to go for that. All right, I want to talk about what's coming up and do a little bit of housekeeping here, and then we'll see if we can get to a couple questions if Mark's got something going there. So coming up next in August, Jody, who's new with us, is going to do expansion tanks, and he's got a background in the expansion tank business, so industry. So he's putting together really, I think you'll learn a lot from that about not only for heating domestic water, but also for solar and chilled water, some of the things that you need to know about sizing and selecting expansion tanks. I'll be back in September, and I'm going to try and put together a maybe a little checklist, or some of the steps that you want to do when you go to a customer's house for the first time when the heat comes on, pre-season checks, what you can do, what's important with some of the new equipment to keep that running efficiently as well as trouble-free. Kevin from our office up in Milwaukee, he does a lot of our certification. He's responsible for getting some of our listings on our valves and being on all the different committees and panels that deal with different listings. So he's going to talk about different product certifications, some of the things like low lead, what it means, how, what's low lead exactly supposed to do for us. He's going to talk about that. He also talks about the listing on some of our thermostatic mixing valves. What's the difference in the listings? What valve you can't use for different applications. So tune in for that one. I'll be back in November, and we've got a lab that we've been working on up in Milwaukee, and it's coming out really, it looks great, I think. But we're going to do a live broadcast from that, so I'll probably do some slides in the beginning, and what we want to do is going to show you a working demo of all of our different balancing valve products. So we've got some pumps in there. We can change flow rates. We can change the valves. We can show you with a pressure differential gauge. We've got an ultrasonic flow meter on there. I think that one's going to be kind of fun and interesting for me at least, but I think you'll get a lot out of it. It'll help you pick how to decide which type of flow balancing valve is right for your application. Siggy will be back in December. Actually, this will be a two-part. It's going to be December and January. He's got a pretty big presentation he's putting together on analyzing the head loss and hydronic circuits. This, I mean, as you can imagine, will have a lot to do with pumps. There's going to be a lot of talk about pumps. What's what type of pump, delta P, delta T. So that's going to be about analyzing the head loss of a system, how you select a pump from a pump curve, how you develop the operating point on the pump curve, and that'll be a great one. And the second part of that will be in January. As always, we're open for stuff for next year. Like I say, we want to get to fluid quality pretty early on. I think we're going to have some really good guest speakers for that have a lot of good information, have a lot of background in that, and we'll talk about that a little bit. And let's see what else I've got coming up here. No survey at the end of this one, but the certificates, again, if you want this, just let us know. We'll make sure that you get a certificate for attending today. And we'll send that out electronic version if you want, so we can get that to you. Usually within a week we can get these filled out. Mary's got a little bit of work to put your name on those and get those built for you, but let us know if you need or want one of those. We got a blog. It just went up Monday, and basically we want to encourage you to go there and talk about things that are on your mind. We're going to, obviously put different things up there. We're going to put some videos. We're going to have some like quickies, like 30-second little videos of different things, a little tool. I think we're going to call them tech tips, some of the different tricks for putting our products together, troubleshooting, working on cleaning and stuff like that. So Kevin and I will be working on that, and of course everybody from the company will be participating, but we'll call it the Ask Caleffi. So if you've got a question about a product or something like that, or troubleshooting or anything really that's on your mind, we'd like to invite you to come over and talk to us a little bit. So that's what's coming up for the blog, and of course the YouTube video are up on our station now. So if you want it more in depth on a product, if you want like a couple minutes on how to troubleshoot a backflow preventer or something like that, we're going to have snippets in the Ask Caleffi that would just be maybe a 30-second. If you need something a little bit longer, a little bit more information, usually the ones on YouTube we're shooting for somewhere between 3 and 5 minutes, so you get a little bit more product information there. And then of course if you really want to drill into a certain product or topics, we'll have all the webinars like we're doing today are archived on the website too. So if you want to drill into thermostatic mixing valves or something like that, and you've got an hour worth of time that you can commit to it, just go over the archive, and there's quite a good selection of different topics that we've covered over the years there, and we'll keep going on that. So I think, Hydronic 15 should be hitting the streets, I think, today. I think coming back from the printer today. So this is going to be a good one. They're all good. This is going to be a great one. And basically what we wanted to do here, issue number 1 and 2, we talked a lot about air and dirt separation, hydraulic separation. We decided not to reprint those. People say, well, you're out of print. We really want the full spiel again. So we said, well, we need to update it. There's a lot more product that we've introduced since we did the first Hydronics 1 and 2. So we said let's just cover that topic of hydraulic separation again in detail with the new product. So number 15 should be on the website here within a day or two, and it'll be mailed out probably within the next couple weeks as it comes back. So keep an eye out for that. If you aren't getting these and you want to get these, of course, go to our website and sign up for them, fill out the form there, and we'll mail the copies as they come out. And if you need some of the back issues, let us know, and if we have them available still, we'll be glad to fill in the missing issues for you there. So, a quickie today. You got anything going on for questions there, Mark? A couple other things here. Facebook, of course, on there. Twitter. We're everywhere. We're the social media guys these days. We've got the blog. We're on Facebook. We can the Twitter account. And, of course, if you got a question, you can call us. We'll still answer the phone. We'll help you. Kevin's there every day in Milwaukee doing tech support, and Nick and myself, and really anybody in the office that can help you. We're glad to take a phone call, too. But keep in touch with us however you're comfortable doing it. So there's some of the options for you. All right, so let's see what we got for some questions again on the insulation topic. Got anything there, Mark? See if you're still tuned in. No, not hearing him. Maybe he's out to lunch. Let me go through the list here, see if any came in. I don't usually watch as I'm going here, but let me see if I can pull it up and see if there's something.
Bob, can you hear me?
Oh, there you are. Okay, go ahead.
Oh, I had myself muted. I think I was the clicker.
Oh, okay.
I had to shoot myself. A question on a solar thermal system concerning insulation. If you have a ground-mounted array and you want to run the supply and return line back into the building, what's the tips and tricks for insulating that line?
I'm assuming he means it's going to be in a trench or something like that, underground or something?
Yeah, buried underground.
Yeah. There's a couple products I've used over the years, and one that I really liked, it was a product that's, I think it's built up in Minnesota somewhere. It's called Insuseal. And what that company will do, and I know that Ravanco up there near Joliet in Illinois will make it also, but they'll insulate PVC pipe, and then you can slide your piping in through it, and they'll put different R values in it, different thicknesses. But again, what you want to make sure of there is certainly close to the collectors that you have a high enough temperature to do that. So what I used to do some outdoor wood boiler work around here, and I would either get that flexible ABS drainage pipe or straight lengths of PVC, and then just get the insulation that works. If it's going to be underground, I probably wouldn't use a fiberglass, knowing that you have the potential to get some groundwater in there. Obviously, you want to seal it as best you can, but I would look at the PVC sleeve and then using the solar insulation on the piping that's going through that. Now, I know what some guys are doing too is they're taking and they're sleeving their pipe inside of PVC, and they're getting guys out there with a spray foam rig. You can actually use that closed cell type of spray foam underground and in the ground, I should say. And it's water resistant once it goes off. So they're digging a trench or putting a piece of foam board down first, like a 2-inch thick foam board, laying either their piping right on that or piping inside of PVC, and then just taking and spray foaming over the whole top of it with a couple 3 or 4 inches of foam and then burying it that way. The beauty of putting it inside a sleeve is if ever something happens to that tube, you can get it out and replace it, especially if you're going to be using a flexible tube like a corrugated stainless like that, and also throw another conduit in that trench so you can pull some wiring through if you want to put some sensors out there. On your collector, you obviously need to be able to get that wire out there, so I would encourage you to put just a piece of electrical PVC that you can fish the wire through and replace if it ever got hit by lightning or something like that. But yeah, more is better when it comes to insulation, especially in the ground. If you're running solar temperatures through the earth, you want to do a good job or you're going to lose quite a bit of it before it gets in to do its job inside the building. So that would be a couple of suggestions: the Insul-Sleeve product, the product from Ravanco, or build your own sleeve and either spray foam it or build a foam box around it.
Great. A couple of points, less a question than just statements concerning the installation of expansion tanks. A number of the listeners were kind of pushing back on that in terms of the merit because the expansion tank doesn't really have any flow through it. It accepts some volume and then it rejects it when the system cools off. And I would agree with that, and that's a true point. But if you put your hand on wherever the piping connection comes in, if the boiler's starting up, some of that heat's going to go in there. That'll be a good question. We'll throw that at Jody when he's on here, and him being an ex-Amco guy would maybe have some more information on that. I know the thermal expansion tanks on top of your water heater certainly get warm, so that would be another place that you want to keep that heat in your going out to your faucets, not into your expansion tank on top of the water heater. But that, yeah, I would agree with that. But maybe for the cost of doing those big tanks and for the bang for your bucks, it's not worth it. So, right. Another question: what happens if you insulate the motor on a pump? What's the problem with doing that?
Well, from what I understand, and again, I'm not a pump expert here, but if you look at the ratings on a pump, it's going to give you a couple different ratings as far as temperature, the maximum temperature, the fluid that pump can do, and I think it's, 212, 220 degrees, 225, something like that. But it also does tell a maximum temperature that the motor can operate, like not only an ambient temperature, but, and I'm not sure, I would imagine on bigger pumps there's a thermal overload near it. If that motor gets too hot, either it's seized up or something like that, it would trip but I don't remember. I know on some of those little wet rotor pumps, when they lock up, man, they get smoking hot. You spit on them and they sizzle. So I would say that pump, part of the cooling mechanism is the fluid that goes through it that cools the pump, but also the ambient air around it plays a part in keeping that motor from overheat and going over the maximum allowable temperature. So again, I would probably send you to the pump manufacturer for an official answer on that one, but that's what I'm imagining is just to keep the pump motor from exceeding the temperature limit on it.
Okay. Here's another solar question. Is there a peel and stick solar insulation available for high temp jobs?
There is. Not the ones that I showed you. What I like about that one that I showed you from that UT, I think that stands for ultra temperature, by the way, that Armaflex UT Solar. It does come with a seam on it. Now I see some that have that secondary flap that goes over that seam. So you peel the double-sided sticky tape off the seam, stick it together, then there's another flap with yet another seal on it. So if it's going to be outside, that gives you a little extra protection and helps hold it together. Now we have up at Caleffi, we have rolls of the tape. I think it's 2 inches wide, and it's a high temperature wrap. So if you come to a T or a fitting or something like that, that you don't have a, you don't want to cut the pipe insulation to try and go around it, you can just take, I think it's a 50-foot roll of 2 inch wide, and it's sticky on one side. And it is a high temperature. It's made for solar applications where you have to wrap the fitting on, say, our solar flex, where the insulation comes up to the fitting. But then after you make the fitting, assure you that you don't have any leaks, you can just take this 50-foot roll and just kind of wrap around it. And it gives you a good tight seal and also kind of glues everything together. So we've got that available in our catalog as a separate item. I think it comes with the solar kits, too. If you buy one of our solar package systems, there's a roll of that insulation sticky tape in there for doing solar connections and high-temperature stuff.
Okay. Another question. I had to step out for a second, so you may have addressed this. As it pertains to insulation in chilled water systems, any particular practices to implement versus a heating system?
Well, again, tight connections. I mean, no exposed metal. Even a seam between two pieces of insulation. If it's fiberglass, they make that seam tape. It matches the outside jacketing on it. It's basically kind of that aluminum with that kind of a rip strand type of fabric that you put over the seams where the two pieces of pipe insulation come together. But again, where you go up to a tank or up to a fitting or up to a valve or something like that, if there's a jacket on it, you really, really have to get a good seal there. I've seen guys carefully use some spray foam, that comes in the can, because that is a kind of an adhesive as well as a sealant. So if it's a spot where you can't really get your tape or your fingers or something like that, I've seen guys, and again, you got to be careful with that. Sometimes you can go back with a knife and trim it off and make it look good, but you really have to, seal off all the spots with where you can get air temperature up against that cold water piping in there. Okay. I think we showed some examples of what can go wrong with that on a couple slides in there if you don't have that sealed up tightly.
Okay, Bob, I think that's all the questions that were really general in nature. We have a couple one-on-ones that you can address, but that's it.
Well, yeah, thanks everybody for tuning in. And again, tune in next month and let us know what's on your mind, and blog us, email us, text us, whatever you are in the mood for. We'd love to hear from you, and thanks again. Have a good day, everybody.